In this video, we're going to look at a new set of identities called our half-angle identities. So you'll need to copy these on your identity sheet. The first one is the sine of theta halves, or theta over 2, equals plus or minus the square root of 1 minus cosine theta over 2. And then cosine of theta halves, or theta over 2, equals plus or minus the square root of 1 plus the cosine of theta over 2. So these two formulas are very similar. One has a minus and one has a plus here, so be careful with that. The other thing, the plus minus in front is either going to be a plus or a minus. It's not going to be both, and it depends on the quadrant of the angle you're finding. Okay, like for example, if I was finding the cosine of 10 degrees, 10 is in quadrant 1, and the cosine's always positive in quadrant 1, so I would go with the positive there. So it all depends on what quadrant you're dealing with as to whether you use the positive or the negative. And then the tangent of theta halves actually has two formulas, 1 minus cosine theta over sine, or sine over 1 plus cosine. So go ahead and write both of those down and be memorizing both of those, but you can use whichever one you want. So we're going to start by evaluating some angles using these identities. Now here's when you're going to use, or when you know that you're going to use half-angle identities, is when the angle that you're wanting to find is not in the unit circle, but it's half of an angle that is. 105 is not in our unit circle, but 105 is half of 210, and 210 is in our unit circle. Okay, so the angle that you're given is your theta over 2. Okay, so the 105 is theta divided by 2. So to do the problem, I have to know what is theta. So in other words, what is this angle half of? Well, that angle is half of 210. So 210 is the angle I'm going to actually use in the formula right here. Okay, so I'm finding the sine of 105 degrees. 105 is in quadrant 2 because it's greater than 90. The sine is the y value. Y's are always positive in quadrant 2 because you have to go left and up. So you're always going to have a positive sign in quadrant 2, so I'm going to use the positive here. Now you don't have to write it if it's positive. It's assumed that it's positive if you don't write it, but if it's negative, you do have to put the negative there. So we don't have to write the positive. Square root of 1 minus cosine of theta, remember our theta is 210, all divided by 2. Pay close attention as we solve these because they can get a little bit tricky. So the first thing that we're going to do is use our unit circle to evaluate the cosine of 210 degrees. Remember, the cosine is the x value. 210 is over in quadrant 3. The x value there would be negative square root 3 over 2. All divided by 2. Okay, so I'm just going to do some simplifying real quick. That double negative is going to become a positive, so I have 1 plus square root 3 over 2, all divided by 2. Okay, what I want to do next is multiply everything in my fraction by 2. And the reason I want to do that is because right here I have a fraction inside of a larger fraction, and I want to try to get rid of that. So since that fraction has a 2 as its denominator, if we multiply each part in our fraction by 2, we haven't changed anything because we've done it to everything, but it gets rid of that fraction. So to do that, my 1 becomes a 2. When I multiply this fraction by 2, the 2's cancel, and I'm left with just square root 3. And then when I multiply 2 by 2, I get 4. Okay, let's simplify one more time. Remember that when you have a square root over a whole fraction, it's like taking the square root of the numerator and the denominator separately. So I look at that 4, and I realize that 4 has a nice square root, which is 2. So I can leave my square root in the numerator, but take it off of the denominator if I go ahead and say that the square root of 4 is 2. And I know that looks crazy, but that's your answer. There's nothing we can do to simplify that any further. So it is okay on these to have a square root inside of a square root. Okay, number 2, we want to find the cosine of pi eighths. Okay, remember that pi eighths is theta over 2. So what is theta? What is pi eighths half of? Well, pi eighths is half of pi fourths. Think about it as just doubling it. If I doubled 1/8, I would get 1/4. Okay, so now I'm going to use my cosine formula here. So the cosine of pi eighths is, let's decide on our positive negative. Pi eighths is in quadrant 1 because that's a very small angle. Cosine is always positive in quadrant 1, so we're going to use the positive. So we don't need to write anything there. And then we've got 1 plus cosine theta, so 1 plus cosine of pi fourths, all divided by 2. So then we're going to go back and we're going to do our unit circle. What is the cosine of pi fourths? Square root 2 over 2. All right, just like we did in the previous example, we tried to get rid of our fraction within our fraction by multiplying by its denominator. Same thing here. This fraction has a 2 as its denominator, so if we can multiply all 3 things by 2, we get rid of that fraction. So the 1 becomes a 2. Square root 2 over 2 just becomes square root 2 because the 2's will cancel. And the 2 on the bottom becomes a 4. And then just like last time, I know that the square root of 4 is 2, so I can take the square root off of the bottom and just say that the bottom is 2, but leave the square root on the top. Be careful with your square roots. Make sure that you show that you're only putting the square root in the numerator and not over the whole thing. It's easy to kind of slip up and let it come down further. But that's your answer. And these are problems that you can also check in your calculator to make sure that you've done them correctly, but we don't want a calculator answer. So for example, the sine of 105. Let me make sure I'm in degree mode first. I'm not, I'm in radian mode. So switch to degree mode, type in sine of 105. I get 0.9659 and so on. If I type this in, I should get the same thing. So let me type in the square root of 2 plus square root 3. Make sure you arrow out of both of those square roots and then divide by 2, and you get that exact same fraction. So you can check that you've done them correctly. Okay, let's do a tangent one. We did a sine and a cosine. Let's do a tangent. The tangent's 157.5 degrees. Remember, that's theta halves. So what is theta? Theta is whatever we get when we double that. So 157.5 times 2 gives us 315. So our theta is 315. Okay, you can use either one of these formulas. I like using this one because it puts one term in the denominator instead of 2 terms in the denominator. So I'm going to use the first one. The tangent of 157.5 is 1 minus the cosine of 315 divided by the sine of 315. All right, 315, remember, is down in quadrant 4, but it's a 45-degree reference angle. And cosine is our x value, so our x value there would be square root 2 over 2. And then the sine at that same angle would be negative since you're down in quadrant 4, so negative square root 2 over 2. Okay, I'm going to treat this problem very similar to what I did those last 2 problems. I have fractions within fractions, and I don't want that. So I can get rid of both of these fractions at once if I multiply everything by 2, since that's what's in the denominator. So basically, I'm multiplying the 1 by 2, which gives me 2. Multiply this by 2, which means the 2's will cancel, and I'm left with square root 2. And then on the bottom, if I multiply by 2, I'm left with negative square root 2 because that 2 there is going to cancel. Okay, now we also can't leave a square root in the bottom of our fraction. So to do that, we do something called rationalizing. We multiply the numerator and the denominator by the thing that we're trying to get rid of. So I'm going to multiply the top by negative square root 2 and the bottom by negative square root 2 to get rid of that. Okay, so in the numerator, I have to distribute this times both terms. So if I multiply negative square root 2 times 2, I get negative 2 square root 2. And then if I multiply negative square root 2 times negative square root 2, I get positive 2. Because a square root times a square root, they cancel each other out. Okay, and then in the bottom, negative square root 2 times negative square root 2 gives me 2. All right, and then we can still simplify further. Think of this as being split up into two separate fractions. This is what it would say. If that was split up separately and you put the 2 under each part, this is what it would look like. Those 2's are going to cancel. So I just have negative square root 2, and those 2's are going to cancel, which gives me a 1. So my answer is negative square root 2 plus 1, or you may want to write it 1 minus the square root of 2. Either one of those are perfectly fine. And you could also check that in the calculator to make sure that you get the same decimal value.